and thanks to everybody who's taken the time today to watch this or with the recording. This is an area that I have been looking into for two reasons. The first is from a consulting standpoint, we've been working with a number of organizations who have concerns or come to us to say, hey, we've got concerns about our CI/CD pipeline. A lot of times when they're moving a lot of CI/CD stuff out to the cloud, and hey, we have a concern about this. Can you take a look at what our build process looks like to make sure that we're not exposing data, that we're not allowing people in and whatnot. And so we've done a bunch of consulting around that with a bunch of organizations as they evolve their CI/CD practices. But also, as Martin mentioned, recently, for the last 20 years, I was the CTO at Denham Group. We were recently acquired by Coalfire about a little over 3.5 months ago. And as part of that process, as part of the diligence process for that, they went through and looked at our ThreadFix platform, and so I had to get reintroduced to kind of what our CI/CD pipeline looked like and how all that how all that was. So that was really interesting to me, just to really dig in and look at the process that we used. And so those two things intersected to this presentation, talking about some different things that I found interesting about this. So we'll talk again about what's your risk exposure based on your build pipeline. We'll give a super brief explanation or talk about threat modeling, really just links out to other materials because of time. I'll talk about the concerns about the supporting infrastructure that runs this build process. And then we'll go through really quickly a pipeline threat model, just a template threat model that you can use, take back to your environment and potentially look. Again, we got a lot of questions on the slide that you can use in your environment to ask questions to understand more about it. And then talk about different ways to use it, both, again, internal facing to increase your security, as well as external facing from a vendor management standpoint. And then I have some discussion points that I will present so that we can then argue about them in the Slack afterward. So there's been a couple notable incidents in this space that leads to this being, again, a topic of interest out in the industry. In the SolarWinds case, their build infrastructure, a server in the build infrastructure was compromised, causing integrity issues with the software. In CodeCove, they had a compromised container server that caused improper changes to their tool that led to a bunch of issues. And this trend, these aren't the only two, this trend contributed to the Biden administration executive order and other government activity in the space. And so it's tremendous, for vendors out there, it's tremendous fear, uncertainty, and doubt. But for practitioners or folks that are responsible for the security of CI/CD pipelines, it's also a call to it's also a call to action. Let's take a look at this potential exposure area that we might not have looked at before. And there's the challenge is there's kind of a fundamental disconnect. I remember when I started my career as a developer probably 25 years ago, and I look at the advances we have made with version control, static analysis, both for quality and security, unit testing, acceptance testing, code coverage. Like the tooling we have available now is so much better and so much easier to use than it was, when I started out my career, in the mid to late 90s as a Java developer, right? We have just amazing tools that put us in a situation where we should be able to create, secure, reliable software at a scale that previously hadn't been considered. The flip side of that is that the way that we deploy and deliver this tooling puts us in a situation where you actually can't trust anything that comes out of the other end. Is really all I can is really all I can say to that. And especially like the deeper into this, or the more that I looked at this, what I really found is these build pipelines have fractal attack surface, right? Where we look and we see, okay, well, I see kind of the general shape. Well, if you zoom in on any of these shapes, you find like, oh, well, this shape actually has a level of complexity where it's repeating a lot of the things before. It has a level of complexity that repeats. And if you zoom in even closer, you see that, same complexity, and zoom in and so on and so forth. And so that's really a challenge that we've found. And I'll talk about some of the sources of this, but if you just think about, we've got code, we've got open source components. We have webhooks, we've got GitHub Actions, we've got everything along the way has a plugin model, and you don't necessarily know where those plugins are being pulled from unless you're being really careful. And so that's a real challenge with these CI/CD pipelines, is just the fractal attack surface that they expose that is can be an ever-changing mess. So from a threat modeling standpoint, again, it's just for time reasons, we don't really have time to dive deep into this. If you want some background, you can take a look. There's some resources out there that are available. But basically what we're going to do is we're going to break the parts of the CI/CD pipeline and the build process down into pieces, watch how data flows between them, and identify potential areas of exposure. And again, we've got, there's a lot of questions that you can use to ask in your environment about the different stages, and we'll outline different concerns along the way. So, what's from a raw concern standpoint, like what are we worried about in the CI/CD pipeline? The potential confidentiality impact of a breach in your CI/CD pipeline, IP disclosures. Organizations have algorithms that are subject to trade secret protection. There are concerns about again, access to source code that people aren't supposed to have access to and whatnot. And if you see how, like, it's been interesting for me seeing how organizations from a legal standpoint will be very, very concerned about the open source licenses associated with their software, because they don't want to be forced to disclose the source by including GPL or other viral components. But organizations are more lax about including components with security vulnerabilities, and that's because that again, a concern about the value of that IP. So that's a big confidentiality concern. Obviously in the build process, you're going to have secrets, used for signing things and whatnot, and so on and so forth. And if your source code is exposed, that puts you at a risk for vulnerability disclosure. Vulnerability data is not typically subject to regulation, but is obviously high value and sensitive information that no one wants to let outside of their walls in an uncontrolled manner. When we look from an integrity standpoint, the concerns are if someone can actually, instead of just being able to see what's going on in the build process, if they can affect it, that's scary, because people can put in things like backdoors or other suspicious, that provides like surreptitious access. And you can also have other unwanted behaviors, crypto mining, DDoSing, things of that nature. And again, just a general compromise of parts along that build chain. From an availability standpoint, in most situations that where we've worked with folks, this is less of a concern. Obviously, you want to be able to build and deploy software. If you're delayed in doing that, that may have an impact, but probably not as acute as a confidentiality or integrity breach. One potential situation where you would have availability concerns. Software today isn't just a monolith that runs. Your client's deployed software might depend on services that you're providing, and so an inability to update those for some period of time may have a negative impact. Now, it's important first to think about the infrastructure supporting your CI/CD pipeline, right? Are these fixed assets? Are these bare metal servers or virtual servers that live for a long time? Or are these ephemeral assets? Virtual servers that pop up and pop down, or containers that spin up and spin down? And how does that fit into your scanning regimen? One thing we found in a number of organizations is a lot of dev infrastructure is managed by developers. And so it may not be in scope for the corporate scanning and patching regimens that they have in place. And that is, the developers tend to like this because it gives them the ability to kind of own their situation, which is great. It's potentially though risky because you don't have, if you're used to having these detection and controls and kind of mitigations in place for the rest of your infrastructure, when you look at your CI/CD infrastructure, like there's a lot of really valuable and sensitive stuff that flows through that. And so, to not have those practices in place is scary. Infrastructure as code can be a help in this, but also, can also be an area that exposes you to risk. And so it's important to ask questions. If you're going to talk to the folks, your DevSecOps folks responsible for their pipelines, start by understanding, what does this support infrastructure look like? Where does this stuff live? And how are these normal information security practices being implemented for that? Another challenge, a real challenge with modern tooling is, like, the perimeter is a freaking nightmare, right? It's a critical part of the threat modeling process is to understand, like, well, what's in scope and what's out of scope. And for for modern CI/CD pipelines that are using a lot of the cool tooling that's available, this turns out to be extremely difficult, often impossible to find the boundary. There's a lot of steps, a lot of moving parts, and what it looks like today may not be what it looks like later, right? And especially as I talked about, you've got actions and apps, and everything has an extension plugin mechanism. Those plugins get loaded from who knows where. You could be running code from almost anywhere, and that code running from anywhere, unless constrained, is potentially going to send your code elsewhere for analysis, for archiving, for whatever that might be. And so you don't necessarily know, unless you've looked at it, where your data is going. And a real challenge here for a lot of security teams to understand, like if you look at how most security tools get purchased, it's kind of a big box, like a monolithic evaluation, proof of concept, procurement, deployment, right? And you've got this big security scanner tool or whatever it is, like doing stuff. If you look at how dev tools get implemented, like it's very different. A lot of the dev tools are freely available, or they have freemium models where you kind of, just by having a GitHub account, like all of a sudden anybody with a GitHub account is a corporate purchasing agent, where they're bringing, spinning up new tools in the CI/CD pipeline. And and that's scary to a lot of security folks, but that's just normal for development teams. They say like, hey, I found this neat new code coverage tool that we're going to use, and as long as we don't use it for more than 5 projects, it's free. I can load it up here from GitHub, right? And most organizations don't have great controls around those, and honestly, it's not easy to implement those types of controls. And so one of the approaches, I tried 2 different approaches, or 2 different things that I looked at when we were kind of dug into this. The first thing I tried, well, hey, let's just watch the net flow data of the build process, right? Like that would be interesting, because we could see like where should this build process be able to talk and not be able to talk, and maybe we could put firewall rules around it or something. I had this like great idea, like, oh yeah, we're just gonna put a wrapper around the process and make sure it only does the stuff it's supposed to do. Like I watched a couple of different software products and the NetFlow data around that, and they talked to everything, right? It just simply wasn't reasonable to sort through that data and figure out, there was so much traffic to so many endpoints that like, how are you supposed to know what's the right stuff to look at or not? So what I like, an approach that I've used, and that we've used in other environments that has had a lot of success, is, well, let's start with a code commit and walk me through the workflow, right? And I know this, it sucks because you actually have to talk to people and ask questions and get their answers. That's less convenient than having like a neat NetFlow firewall model to do things. But again, that was something that I found that worked. And so if you look at an example CI/CD pipeline data flow, again, everybody's is, every product is going to be different, or every, applications is going to be different. But this is kind of the idea. You've got your developer, they're committing code to a repository, you're pulling open source components, you build that into a binary, that binary gets run through a variety of different tests, you make some sort of an evaluation. If the build passes, then that gets passed into some sort of a build repository and then distributed out to others, right? That's again, your process may have different steps, may have different controls, but this is at least a template that you can work from, augment and kind of customize it for your environment. And so what do we want to do? Again, talk through the code change, change the code, run the build, automated testing, accept or deny, push to distribution, and actually distribute the software. And as you're working with folks in your environment, you want to ask questions at each stage, right? And like 2 really important questions that I've found to ask are, well, how does this step authenticate itself to the next step, right? Like, how does this component let the next component know, like, who it is, what it's doing, like what sort of access it's supposed to have, right? Like, how do the steps go from one to the next? Because that identifies a lot of potential concerns. And also, answer me a simple question: where is the server, right? Like, where is the server or service that is performing this step, right? Like, where does the data have to go, and where is the code going to run that's actually going to perform this action before moving on to the next one? And this should be a show activity, not a tell activity, right? You want to be, show me the screen, like show me the user interface, show me like evidence of why you think this is behaving as it is, because that's not, it's not always, it's not always obvious. Now, some general overarching concerns. There's a tremendous amount of network traffic that goes into this. Again, from the NetFlow example, how is that traffic being protected? Again, like let's make sure that we've got TLS in place to guard confidentiality, integrity. And as I mentioned before, there's a lot of authentication points where you have you have users authenticating themselves to systems to do different activities, but you also, along that build process, you've got systems authenticating themselves to one another. How, just understand the mechanics. How is that happening? And do you have an overarching, identity and access management paradigm in place? Or more likely, is there some sort of combination of overlapping approaches of how these pieces all fit together, with their credentialing? Also data storage. How is data at rest protected if it needs to be? Especially for like file and block storage. And what are your what are your unknown unknowns, right? Like where are you identifying things as you talk through this with a DevSecOps engineer? Where are the places where you get the what we call the two shoulder salute? Like you ask a question, they say, And again, like a challenge here is like any developer with a GitHub account is now potentially their own purchasing agent, which is for a lot of security practitioners is really a terrifying concern. So if we look at some specific concerns about source repository workflow engines, so you've got sources of code, stuff that you're writing in-house with in-house developers as well as potentially third-party development teams. What does it look like for that code to get into the system, right? Are merge requests being reviewed by one or more other developers? What does it take for code to get into the system? And also, how do third-party development teams get their code into the environment? And a pattern that we've seen in a number of cases and that we've used is to have multiple, like a bastion host Git repository or a proxy Git repository where less trusted developers put code, they can go through their whole process. And then before that code makes it into the main code base, it can go through a more elaborate, again, checking for security vulnerabilities, checking for potential backdoors, but it's a very explicit step to say, we're going to take this less trusted code from a third party and bring that into our environment. And so that's something to, that's one technique to potentially look at, but you need to understand like what checks are placed before code finds itself in the repository. A really interesting question that I dug into with some folks is authentication. Like, how do people authenticate to these repositories, right? Are developers like how do they authenticate to push and pull code? Are they using certificates for that or some other means, right? How do developers log into the user interface to evaluate merge requests, right? How do external systems call into APIs? And so what you can find is a situation where the source code repository has certificates being used for certain types of access, usernames and passwords. Maybe they go back to LDAP or AD. Maybe you have API tokens. And so like that's a scary situation to be in where, hey, to authenticate to the system, there's these different ways to do it. And again, looking at, what other hosted repositories and workflow, do you have things configured where they're going to run different apps, different actions, integration for GitLab, all these external collaborators. And so it's important to kind of dig in and understand, how do people access this? Well, how do they do, again, how do you do code? How do you access the user interface? How do API or other components talk to this? When you look at the open source component management, a question you've got there is, are you pulling these components directly from the central repositories, or are you proxying through some sort of a service that allows you to enforce policies, right? Where you can say like, hey, we're not going to allow things with certain licenses. We're not going to allow things that have known vulnerabilities at a certain level or something like that. So that's another choke point where you have some control. Where it's where it can be important to understand what controls you have in place. And that's, again, if you're pulling directly from central repositories, there are a number of products out there that'll give you some control over this. A lot of organizations we talk to have concerns about open source backdoors. none of them have the resources to actually maintain this to check this themselves, right? Again, problems with PHP or concerns with PHP, Linux kernel example, where people were like intentionally submitting security vulnerabilities, like write a paper, like, come on, jerks. Like, and so this in a lot of cases isn't realistic to detect, but it is important to be able to respond. And so if you have good practices around open source management, you should be able to know, again, software bill of materials, things like that nature. Hey, what components do we have in there? We know that the backdoor has been disclosed. Let's go identify how that actually impacts us, and so that we can go back through the process of getting an improved build out. Now, if we look at the build management systems, right? It's a question you're combining. Again, you've got your source code. You're pulling in these external components, to combine that and create a new build. And how do those get run? Are those run on every merge request? Are they run on accepted merge requests? Are they only run on specific branches and tags? It's important to understand, how do these systems get initiated? And that was something when I dug into to our environment. Like I learned some things about what we were doing that I didn't expect. And that's good. Nothing nefarious, but it was, I was able to understand, like, oh, well, GitLab kicks off on these types of things, and Jenkins only weighs in on other types of things, right? A total nightmare is Maven plugins, right? Like, that's another source of code that you can't trust. It's going to run in your environment. It's going to get pulled from repositories out in the middle of who knows where, right? Like, that's really scary. Again, all of the plugin capabilities in these build management tools or tools along the tool chain makes it really challenging to understand, like, what is actually being run. Then if we look at automated testing, again, unit testing, acceptance testing, all types of new, static analysis and things like that. That's great, right? For static analysis, like what's being analyzed, source or binary, where is that being performed? Is it performed in your environment, or is an artifact being sent out to a cloud environment for that processing? There's no wrong answer there, but you want to know the answer. That's the important thing, right? Where are the results being stored? Are those stored in your environment, or are those stored on some external server, for a cloud provider? Again, no wrong answer, but you need to have an answer. Same thing with dynamic testing. Where is the server that is being tested hosted? Where is the test traffic being generated? What does it pass through, such that people might be observe or modify that? And where are those results being stored? Same questions for IaaS software composition analysis. Again, like where's the data moved to for the processing? Where are the results being stored? I have to give a shout out. There's a lot of concerns about backdoors, and like one of the most interesting talks I saw was a long time ago when OWASP had their conference at the eBay headquarters a million years ago, and I saw Chris Wysopal give a talk about like automated backdoor detection, and so that's something that is, and he gave some examples of open source or disclosed applications. Like, hey, if you search for this pattern, you can potentially find this nefarious behavior. Like, first of all, like from a backdoor standpoint, the easiest way to insert a backdoor often is to have a bad person introduce a security vulnerability, because that gives them deniability. What I'm talking about more from this backdoor detection is, how do you look at the behavior of the application to identify hard-coded credentials, something of that nature. I think this is it's an impossible problem to solve, and it's a really challenging problem to like even reasonably solve at scale, but I think that's an area of potential, of interest. Now, if we look at the software getting packaged and distributed, like what does that look like? You've got monolithic applications, microservices applications. What are you actually distributing? Code signing is great. If you're using it, that's fantastic. But that doesn't solve the problems of backdoors or vulnerable code or other issues, because it merely like freezes in time and blesses what's come through the process. If you've had problems earlier in the process, this packaging and onto distribution, there are you may just be baking in problems that you had before. And then finally, for the distribution, how is this being distributed? Are you distributing binary? Are you distributing containers? Are these containers that get pulled from a container repository? Again, asking those questions: where are these containers hosted? How are they signed? are they being pulled over in a network manner that is that like helps to prevent tampering and things of that nature. Right, and so that's kind of a speed run through the different steps in the process. And again, you'll pull the slides and take a look. But those are some concerns to look at along the way, and some areas that I've found are good to highlight. I know. So how do we use this threat model? By building out this threat model, you can identify where are the gaps in your own pipeline. What can you shore up? Are you pulling open source components in a way? Are you pulling open source components in a way that you don't have the ability to put a lot of controls on those, or are you able to implement policies in those places, right? And a lot of stuff you're gonna find you have to live with, right? The best way for security to get marginalized is to slow down the development teams that are working on key strategic initiatives, right? And so there are a lot of scary things in modern CI/CD pipelines that security folks just have to live with. But it's also, again, knowing about what your exposure looks like, knowing areas of potential weakness, that puts you in a situation where if you suspect there might be an issue, that you can have a response plan. What do we do if we find out that we've accidentally included a component with a backdoor, right? What do we do if we find out that, what's the implication if we find out that a build server, a long-lived virtual machine, has had some sort of a compromise? How does that flow downstream, right? That's a lot better to know before there's a problem than once there is a problem. This is also something where you can have meaningful conversations with the suppliers of the software, right? When you look at vetting from a supply chain standpoint, there's kind of two things that you can look at. You can either, you can both look at, or the two things you can look at. One is, let's look at the application, the current version of the application. We'll do some testing, identify potential vulnerabilities, and then potentially kick that back to the vendor and say, until you fix this stuff, we're not going to buy the software, or you have some sort of a service level agreement that you have to fix this stuff. But you can also look at people's practices to understand, from an open SAM or OWASP SAM standpoint. Hey, talk to me about what practices you have in place, and you can ask questions like, hey, tell me about what your build process looks like. Okay, it all runs in the cloud. Great. What controls do you have in place to make sure that developers aren't including risky, scary stuff? Again, from vendor management, all the code cov stuff, like everybody all of a sudden is like, oh no, like, hey, are any of our vendors using code cov? And let's go like freak out about those folks. And then you ask the question, wait a minute, are we using code cov? Because maybe we've got something that we need to deal with ourselves. So I've identified 4 potential discussion points for the Slack discussion. Software bill of materials, great idea, or literally the least we can do for supply chain security. Also looking at developers versus security tools. How do developers get access to such cool stuff so easily? There's been talk about parallel build pipelines. Really? Really? Hard enough to build one pipeline. Now we're going to build and manage 2. And backdoor detection. Is there any way to do this at scale? So now I think we're right about on time, and Arden is probably about ready to play the music and use the hook to pull me off stage, but I will hop over to the Slack channel and looking forward to hopefully talking to some folks there.